Elasticity of demand, geometric method or point method. When the demand curve is linear, we can use geometric method to measure elasticity of demand at a point on a demand curve. Look at the demand curve AD. It is linear. It has a uniform slope. Suppose we want to measure elasticity of demand at point B. We can use the geometric method. According to this method, the formula to calculate elasticity is length of the lower segment of the demand curve divided by length of the upper segment of the demand curve. The length of BD segment is 1 centimeter. The length of AB segment is 3 centimeters. Then the elasticity of demand is 1 by 3. It is less than 1. At point B, the demand is relatively inelastic. This is the way that one can measure elasticity using geometric method. This method is highly useful to prove that the elasticity differ along the demand curve even if the demand curve is linear with uniform slope. Take point E. It is exactly at the middle of the demand curve. The length of the lower segment is 2 centimeters and that of upper segment is also 2 centimeters. Using the formula, the elasticity is 2 by 2 equal to 1. At point E, the elasticity is unitary. Consider point C. There, the lower segment is 3 centimeters and upper segment is 1 centimeter. Three divided by 1 equal to 3. 3 is greater than 1. Hence, demand is relatively elastic at point C. Using the same technique, we can estimate the elasticity at points A and D. At point A, the lower segment of the demand curve is 4 centimeters. The upper segment is 0. 4 divided by 0 is equal to infinity. There is perfectly elastic demand at point A. We shall now find elasticity at point D. Here the lower segment is 0, the upper segment is 4. 0 divided by 4 is equal to 0. Hence, the demand is perfectly inelastic at D. Here, the thing that we have to understand is, though the slope is uniform and the demand curve is linear, the elasticity is not the same at different points.